Alright, here in this video we're going to look at 12.2, matrix multiplication. Scalar multiplication. We're going to see two different types of multiplication today with matrices. We're going to look at the easy one first, which is scalar multiplication. When a matrix A, for example, is multiplied by some scalar C, you must multiply each entry by that scalar. Now this is going to be exactly what you would imagine this would look like. We're going to be essentially distributing this 3. This is called a scalar, which might sound similar to you in terms of like scaling, like a scale factor or anything like that, which just tells us that we're multiplying everything by the same value. So we're essentially taking this matrix and just tripling it. So we get a 3, a -6, a 12, and an 18. And that's all it is. You know, scalar multiplication, very easy. When you have that negative sign out front, same concept. Just think of really that we're just distributing a -1. Another way of looking at this is that all entries in the matrix will simply change signs. So positive will go to negative, negative will go to positive. And even if the matrix gets, larger, 3 by 3, whatever, we're still just going to be distributing in. So all the values on the inside of this matrix will receive, through multiplication, a -2. So we get a -6, +2, -8, -14, +18, -4, still a 0, -10, and a -12. And that's it. That's scalar multiplication. Very simple. Alright, where we'll kind of see that is in solving matrix equations. So we've discussed different ways of solving these. We're looking for this matrix right here. But there's some other stuff in the way. We'll talk about how to get rid of that 2 here in just a moment. But we also need to subtract this piece away from both sides. But before I'm able to do that, I can't just subtract this matrix currently. We'll first need to get rid of that scalar by distributing it on in. So really this matrix is a 6, a -3, a 9, and a 12. Now that's what I'm going to need to subtract from both sides. Okay? So really if I just subtract that matrix from both sides, that's going to get us closer to our solution here. Okay, so these would cross off. And now we'd have 2 times some matrix x is equal to what we get when I take this matrix and subtract that. Now we'll have to be careful here, looking out for double negatives and things like that, but I'll do an 8 minus a 6 to get a 2. I'll get a 5 minus a 6. 5 minus a -3. So we're going to be adding on 3 there to get an 8. And then we've got the 11 minus a 9 to get a 2. And a 0 minus a 12 to get us a -12. Okay. So once we have that here, this won't really matter too much, but it's an important concept to grasp, is that there's going to be no such thing as division within matrices. So we won't be able to have the option here to say, I'm going to divide everybody by 2, which is what we'd normally do to solve for that x if it was in a regular equation. With matrices instead, what we do is we will multiply by fractions. So, instead of dividing 2 to get rid of that 2 with the x, another option is to multiply by 1/2. And then I can do that on this side as well. And it's now a scalar of 1/2. 2 times 1/2 cancels out, leaving us an x. And then this x answer will come from multiplying that scalar of 1/2 into all of those values. We have a 1, a 4, a 1, and a -6. Okay, Now, a reasonable amount of math took place here. Is it possible to check these equations just like regular equations? Absolutely. And what this process would look like is to take this matrix of X, plug it back in here, and make sure that we get the same final answer. Okay? And we'll just show that really quickly here, because although this concept appears easy, I do have a lot of students that struggle on solving matrix equations because they overlook them and don't double check for small mistakes. So I'm going to go ahead and kind of double check this by plugging it back in, recognizing that the first step would be to multiply it by 2. So I'm going to take this X matrix and multiply it by 2 here. And when we're multiplying it by 2, that's what it'll end up looking like. Okay, and then what we need to check is if I add it with all of this, which we expressed here in the red. So if I add it with that red matrix there, which was a 6, minus 3, a 9, and a 12, we want to make sure that's equal to that original matrix here, which was an 8, a 5, an 11, and a 0. So we have 2 plus 6 gives us the 8, 8 minus the 3 gives us the 5, 2 plus the 9 gives us an 11, and negative 12 plus 12 does in fact give us the 0. So what this means is, by plugging this X back into the original matrix equation, solving it all the way out, we can then confirm that this is indeed the correct answer. Alright, so before we move on to the next type of multiplication, which won't just be a number out in front, a scalar number, but actually multiplying two matrices together, let's kind of have a note to myself here of a little check-in with all the different classes. If it's B period, let's make sure everybody's awake and with us. You know who you are out there. If this is F period, let's make sure we all have our iPads put away and that we are focused and working in on the notes, because this is all brand new material, especially the part coming up. And if this is G period, our gentleman in the front and center desk spot, let's check in with you, make sure that we're doing all right. And make sure we're focused in here and paying close attention. All right, matrix multiplication. This is going to be when we're multiplying not just a number out in front, but indeed two matrices multiplying here together. We'll take a look at it from both directions. Is it the same? A times B, B times A. And then we'll move on to the back side. All right, so matrix multiplication is a man-made concept. All right, so that's why it's going to seem a little strange. Now I'm going to fill this in, kind of show you how to do this first in a little bit, and then we'll speak to why it is set up like this. Here's the way it works. You're going to multiply the elements of a row in the first matrix by the corresponding elements of a column in the second matrix. Now here's what the answer will never be, and this is what people want it to be, but I'll show us why it's not the case. People will want to do 2 times negative 1. Then they'll want to do 1 times 3. And that would be great if that's the way that it was, but the reason that it's not going to work like that is because that would very limit the possibilities of being able to multiply things very quickly, because matrices are all about data, storing data, working with data very quickly. So I'm going to have us work through this example. You'll be a little confused at first, but then we'll see another example of, I'll show us one of why it is like this. So here's the correct way to take this down. We're going to multiply these elements of this row by these elements of this column. I'm going to set up a big matrix down here. Okay, so the first entry is going to be 2 times that negative 1, and then you're going to add it with the 1 times the 0. All right, and this addition sign, That's just a part of the formula. We'll see that that's always going to be there for us. All right, and we'll come back and simplify that here in just a little bit. But I want to keep rolling so you can start to pick up on the pattern some more still. Okay, now what we'll need to do is keep the same first row, but multiply it by this second column and put its answers over here. So it'll be the 2 times the 3 plus, and that plus this comes with the formula, a 1 times a 4. Okay, so then you might be wondering, well, what's going to come next, Mr. Caudill? Because we did the first row and the first row and the 2 columns. As you might be able to guess, is now going to be this second row times this column. And it's going to fill in this space here. So I've got a -3 times a -1. And then I've got a addition sign with the formula. And 0 times 0. The final phase of this will be keeping that same bottom row, multiplying it by that last column. So I've got a -3 times the 3 added with 0 times a 4. Now when we go back and simplify this, we're going to end up with another 2 by 2 matrix. So let me go ahead and do that for us. And with multiplications, this would be a -2 plus a 0. This would be a 6 plus a 4. This would be a +3 plus a 0. And this would be a -9 plus a 0. And when I finish simplifying all those different pieces, we'll get a -2, a 10, a 3, and a -9. Okay, so that's going to be the answer. Now, doing one of these is not going to be nearly enough to help us understand this concept. But let me explain to us why it works like this. Because you might be saying, Mr. Caudill, that's the dumbest thing I've ever seen. Why would they choose to multiply it like that? Here is why. I'm going to show us a nice example using, footballs in season. I'm going to draw us up an example here and explain why it's done in this way to help us generate a lot of information very quickly. Alright, and you don't have to write this part down, but what I've got here is a matrix with all the different ways you can score points in a football game. 1 point for the point after touchdown, 2 points for going for 2, or safeties, which I could have technically added another spot on this matrix for safeties, but whatever, so we can put all those into the same category because they're both worth 2. 3 points for a field goal, and 6 points for a touchdown. Now, if we make another matrix with different teams, I've got U of L, UK, Indiana, Ohio State, what we could now come up with very quickly, especially using technology, when I multiply this row by these columns, we would be able to generate the total amount of team points that team scored in their football game. And I could do that for as many teams as I wanted to very, very quickly. And that's why matrix multiplication is set up the way it is, so that I can take this matrix, which is kind of like a key decider and how many points a team's going to score. We could list out all Division 1, Division 2, Division 3 schools, whatever, all in one giant matrix, have a calculator multiply it together for us, and we'd get all the different teams' final scores. And that's way, way more powerful than just being able to multiply this times that, and that times that, and that times that. Because if that was the case, if I was going to find the final scores for all 4 of these teams, I'd have to have 4 different matrix problems set up. But with this man-made construct of matrix multiplication, now I can accomplish it with just one matrix and then multiply by all the other information I want to find in one matrix. And we'll get to explore this some tomorrow when we're working on this ice cream shop problem that you all will see and hopefully really enjoy. Alright, so now let's pick back up with